Hello guys, my name is Arun and welcome to my channel. This is a series of tutorials on Fortran Programming. Now in the last tutorials we saw about some format specifications meant for read and print statements. Now I like to continue on that. I just not much, but just one more topic which I forgot to add in that tutorial. It's regarding the format specifications for characters. Okay, now suppose you have a character like this, and if you want to read and write them, okay, what you can do is that you can go for read statement, and instead of normal formatting like this, you can write some formatting like this. What does this mean? And AC. Okay, what does this mean is that uh, A stands for the format for names or strings, and this 40 represents the number of characters you are allowing to the string to have. And now since this is just a character variable, it will just take only one, and 40 will not be necessary. On the other hand, if I just give a character name like 10, okay, now the character into 10, this means this becomes a string which can take 10 characters up at the maximum. So this is how it goes. Okay, now let's see. Now if you have to print this, what you can do is that print in the format, all you can do is just type A10 comma AC. Now if I just hold on, sorry, I forgot, you have to close this in parenthesis. Now if I compile this, no error, build this, no error, and then execute this. Now you have to look carefully where you are, since I haven't put any print statements. So 5 comma minus 5.2 comma 14.56, and it's waiting, because now in this line the read statement is waiting at here, so I have to give a name, something like, okay, QWERTY. Okay, as simple as that. Okay, now this is actually the specification for strings, and now based on the string names, okay, you can adjust accordingly, and this goes over, then this goes fine also. Now this goes fine. I'm just adding it here for you guys to have a look. A10 something. Okay, now A stands for character string, 10 number of spaces in the field, as simple as that. Okay, now with that we are closing formats, but I have to give you guys a little information. These are not the only format specifiers available in Fortran. There are a little more complicated Fortran format specifiers which serve a bigger purpose, but we'll not be dealing with that. And for most of the practical applications, these formatting will be sufficient. Okay, but if you guys really wanted even more complicated expressions or formatting, and you can always refer books or Google it up, or refer some reference manuals. Okay, that is purely based on your thoughts, needs, and besides, so these format specifiers have some descriptors also, which tend to make a little modification, which may tend to make a little modification sort of stuff, and do a little logical writing and all, logical reading and writing and all. Okay, so this is optional, but if you guys want to know about it, you can have a look, but I doubt that you guys will need it on a very serious practical basis. But on as always, if you guys need it, you guys need it, you can always go ahead and have a look on your own. Okay, now let's close this up. Let's and have a new file, save it, and now in my folders, in my Fortran tutorials, I create a new folder called as arrays. Finally, we're back into arrays, and I'm going to save this in the name arrays.f95. Okay, now this program is to demonstrate the use of arrays. Okay, demonstrate the use of arrays. Now what we'll do is that in this program we'll try to find the Fibonacci series for the numbers. Okay, and now so I'll update this. The program demonstrates the use of arrays by finding the Fibonacci series. Okay, I think I haven't enabled this up in the top. Enable this, and on indentation, yeah, spaces, yeah, Fibonacci, using Fibonacci series. There are multiple examples. I'm just going with a simple one so that you guys understand. So program fib array, okay, and program fib array, okay, and these are trailing spaces we don't need. Implicit none. Okay, since this is a series, we actually do not need to require real numbers here, because Fibonacci series is integer series, so we don't need real numbers here. So what I do is that I just create an integer, okay, and then to make sure this is a series, what I do is that I enter a value, keyword that we used in the strings to make string arrays, that call as dimension, and inside it I'm keeping it blank. Okay, I'm keeping it blank as of now, so let me make this as 10 to start with, and I say this as fib array, okay, fib vals, okay, and then I need two integers. I need an integer called as let's see, I just need one integer for some looping statement. I call it I, and this is all I need for a Fibonacci series. And now there are multiple ways to calculate Fibonacci series. The one with the array is extremely simple. I'll explain you guys how. Now what I do is that fib vals, open the value, and I make it the first value of it to be 1, and then okay, and then I put fib vals 2 equals 1 again. Okay, okay, I'll just make this as 1. Okay, and now I'll just start a do loop. I equals, let's see, 3 to say n. I need one more. Okay, and I just start a print statement, and to use the format, let me create a format. Okay, and I just need n. Okay, 5 format. Okay, enter the number of values, number of series, okay, enter the number of values in Fibonacci series to be displayed. Okay, now this will pop up an error. Okay, so what I do is that I just type and here, and then what I do here is that I write the format specifier. I will not be using more than 10, so I2 is, let me just click I3 is sufficient. Okay, in this do loop, what I do is I just end it here. Okay, what I do is that it's simple. Fib vals of I, okay, equals fib vals of I minus 1 plus fib vals of I minus 2. As simple as that. Now to print it, what I do is that print with I use another do loop. Do I equals 1 to n, and do print. I don't need any format here. Okay, I'll use a format. I'll use I comma fib vals of I. Okay, here the format I'll use is 10, and I'll give the format here 10 format the Fibonacci value comma I3 within spaces is, give a space, and then I type this may be big, so I'll just type I5. This will do. Okay, now if I were to compile this, I'm just getting a error warning here. It's not an error, but some. Okay, what I have to do is that, suppose if you, I might have told you guys in the earlier tutorial, but anyway, just reminding, suppose if your line is too long, and if you want to display the line or write the line in multiple statements, okay, what you have to do is that put an AND statement on the last, and then start the next line with the same AND statements. Sometimes in the previous versions of Fortran, all you have to do is that put this AND statement, and you don't need you'd have to need this to continue. Sometime in the newer versions, you don't actually need this, but sometimes you just throw a little warning. Okay, but it's a good practice to use it. And sometimes, so if now I compile this again, there's hardly any error. Not only AND statement can be used, sometimes any other statement can be used, but the provided okay, the same statement is it's not like that. I think it has to be an AND, because I heard from one source, I think I might be wrong, I heard from one source that you have to use AND, and you can use any symbol. Okay, I think it's probably AND alone, because AND is most commonly used. Anyway, this has to be done. Now what I'll just walk you through the code. Now we define at the maximum 10 valued integer variable. So it's an array. Fib underscore vals is an integer array having 10 values into it, 10 integers into it, and we define two more integers, I and n. Now I don't need a print here, I need a read statement here. Now what I do is that I read the value n from the user, and the format with which I read is given by this formatting statement. So I do not expect, as of now, I'll enter a value less than 10 at the maximum 10 here, so that this dimension meets its need, then what I do is I just define these two values initially. The first value of the first value of the array and second value of the array, and from the third value on, what I have to do is that I just start a loop with I equals 3, and we'll go all the way till n. For each value of I, this fib value of I will be the sum of the previous two values. So if it's 3, this will be fib2 plus fib1. If it's 4, this is fib3 plus fib2, and that's it, and so on. So this way, this loop will calculate, and once all of this is calculated, this loop statement will print the values of I and in fib underscore vals of I in this format. So it will be like the Fibonacci value of 5. The Fibonacci value 5 is this. The Fibonacci value, okay, like Fibonacci value of 6 is this, like something of that sort. So we compile this, edit this. Yeah, instead of doing the shortcut key available in terminal, let me just do this in the terminal itself. Now we are in, let's go back one level. If I just click ls, there is this folder called as arrays. I go with arrays. I go there. All I can see is these files. What I do is that just remove these. Click this .o. Yeah, okay. Now what I do, instead of doing a two-step compilation procedure to get your executable as per your name, there's another way to do that. What you do is just type Fortran and then type your file, and then what you do, you just type this minus o flag, the o flag, and then type is this arrays? Yeah, and then type this fib.exe. okay, and you click enter, it works fine, nothing pops up, but actually this executable gets created. So if I just type fib.exe, okay, and click enter, there's a problem here. At line 10, wait, at line 10, let's see, a constant string in input format. Okay, sorry, I forgot. This cannot be used because this cannot be used because you cannot pass printing statements here. So I kind of messed it out. Now I let's see. I just make this as print. Okay, I just print this as I just print this as n. That will be fine. Okay, now I just read this. Okay, I just read this file. Okay, yeah, this will do. So if I just have to compile this again, if I were to do this file, it won't show me anything. If I just enter a value like 5, it'll print them. Okay, now if I were to run this again, okay, I'll just raise the screen up a little. Yeah, if I run this value for up to 10, it will print all the Fibonacci value from 1 to 10. Okay, suppose if I were to do this for 15, it will throw me an error. Watch. Oh, funny, it didn't throw. Sometimes sometimes the allocations kind of adjust, but if I were to be a little ambitious and if I put something like if I were to be ambitious and put something like 2003, okay, no, Fibonacci series can get too messy afterwards. Let me put something like 25. Yeah, you get this issue. you get this something called as segmentation fault, because if you see, this array is only designed to hold 10 continuous memory allocations. See, an integer holds 2 bytes. Because of this dimension, it holds, this fib value holds 20 bytes of memory, so it can hold 10 values. Sometimes, as a backup, what the arrays do and the compiler does is that it saves a little more memory, just in case if values go a little out of control, or just to do some processing afterwards. Okay, but what segmentation fault is that it comes whenever a certain memory which is not allowed for the program or variable to access gets accessed in the process. Since it's 10, okay, I'll just do this again. If I just give 10 at the maximum, it's still within the limit. But if I do this with 15, okay, only up to 10 is within the limit, but this value 11, 12, 13, 14 and 15, they are not within the limits of fib_vals array, but they are little like a buffer memory kept for the compiler, in case if it needs a little more values afterwards. Okay, but if I go something like 20, it shows segmentation fault, but it still proceeds a little more to give an answer. But if I were to go like 100, this will blow up. Because if you guys notice, after this the formatting goes out of control, but it's trying its best to do something about it. Yeah, but because of this formatting, these values are getting starred. Okay, so let me just make that correction over here. If I just make this as I10 or something, let's try this again. Let's try this again. Yeah, exe, I give something like 100 again. Watch. Yeah, perfect. This is what I meant. This is what I mean. Okay, you see, up to 46 it's working fine, but after that, look at the values of the Fibonacci series. They turn into negative. It does not mean the Fibonacci series cannot turn negative, but its values are negative. Why is that? It's because it's trying to access memory locations that is not available to the do loop and this fib_vals array. They are trying to access, both of them are trying to access values that are not available or within the regime of its memory, and because of it, it's trying to access some memory which is not in it, and that value might have some junk value or answers or garbage answers stored during the previous operation processes and all, which may not have been cleaned. And when those values get used up, the results get corrupted, and you come up with this completely random and not at all plausible answers. So at the maximum, all I can say is this is the limit up to which more or less the memory location allocated for the program is working. Beyond that, the buffer memory is lost, and then whenever it tries to do that, it just accesses memory that is beyond its allocation, and somehow the program is proceeding, but it does gives a warning that some invalid memory reference has been made, called a segmentation fault, and it's telling some issues that the code is dumped and all. Okay, this is something you have to work with arrays. And now suppose I know that I cannot be just contented with, sometimes you might know that I just kept only 10, but this may not work. So how can I rectify this? Sometimes what you can do, I'll explain this again. See, by this program, by defining this dimension to be 10, okay, I'm setting a limit on the array, but sometimes you know that the setting a limit may not work. You might need a condition wherein you have to go for like 100 variables, 1,000 variables, or 10,000 variables continuously. There are some functions, by the way, there are certain programs wherein you need that much of memory. Maybe for simple things you may not know, but there are a few programs for which you need that. So what I do is that to make that possible, type a colon, okay, and in front of it type a keyword allocatable. What does this mean is that this calls for a concept called as dynamic memory allocation. See, whenever in all this time, in all the tutorials we saw, all the variables get a certain piece of memory allocated to them in a static manner, meaning while the compilation execution itself are done, or the compilation building is done, the codes in the machine codes in the compiler, in the object files and executable files, allocate a certain bit of memory before doing all the processes pre-hand. Now what does this allocatable statement does is that it gives a little leverage to allocate the memory during the execution, so that it fits the context, it fits our need properly. So by default, you see, the compiled programs are faster because you're able to allocate the memory beforehand, and do a lot of processes by optimizing the machine code. But this allocation process makes us easy, but makes the job easy for us, but it makes the job a little difficult for the compiler, because it has to give some remove some optimization processes to make sure the allocation happens. So it's the allocation process, or dynamic memory allocation, becomes a little slower, but it works a lot. It becomes really helpful. Now how do we allocate that? It's like this. Now as and when I get a value n, what I do is allocate now fib underscore vals, okay, and then inside the bracket I put n, okay, and then that is it. And then at the end of the program, okay, if I want to remove this allocation, all I have to do is that I have to type a keyword allocate, deallocate, and then the array fibvals, and that's it. Now what this does is, I'll just write a comment over here, allocates n times integers to the array at runtime. Okay, as simple as that. Yeah, as simple as that. Okay, and here what it does is deallocates the array. As simple as that. Now if I were to try this up, let's see. Now if I were to try this up, if I just try this up, I just have to execute this again. Once this execution is done, if I give a value like 50, watch, still going negative. Okay, but at least it's not showing any segmentation fault and all. Okay, now I think this is because of the formatting stuff. Okay, now let me change the formatting a little more to accommodate this stuff. Let me make this 15. If I were to compile this again and execute this, the same value 50, it works fine, but it's still going negative. Possibly big. Okay, I'll just compile this again, build this again, and execute this. Give 50. The same repetition values, but there is no segmentation fault error here. This is segmentation fault error here. So I'll just let you guys know. I seriously don't know why this turn becomes negative. So even then, here. Oh yeah, okay, now I get it. See, I think the reason why we're getting negative here is attributed to two reasons. Okay, it's attributed to only one reason. In the previous time, this became negative, possibly because of lack of memory allocation, lack of memory allocation due to segment fault issues, and because of uh, because of uh, the because of limits of integers. See what I mean is, see, an integer with only 2 bytes by default occupies 2 bytes of memory, and there's a upper limit on the number of values the the upper limit on the values an integer can store. So for instance, we just go to Google. Okay, I'll show you guys what this means. Let's type integers, integer numbers. Okay, integer definition. Let's see. Let's go to Wikipedia. I think Wiki will have a proper documentation of it. And my internet is pretty damn slow here. Okay, in compute, let's say whether there are some computer explanations of it. Yeah, in computer science we need this one. Yeah, because this goes for mathematical integers and this goes for computer integers. Okay, now if you guys notice, there are several types. If you guys go through this entire stuff, there are you don't have to go through everything, but there are some rules and regulations as to how many values or how much the value numbers can be stored in an integer. In mostly there are two types of integers, like signed and unsigned integers. Okay, if there are n bytes or n bits, the number of values bytes can store depends on that. The max upper limit on the number can be stored is depend on that. So these are some representations of the different types of numbers that can be stored. The different limits of numbers can be stored. For instance, if there is an integer that holds only 4 bits, literally that means half a byte. Then if it's a signed integer, meaning you can take from negative and positive values, the limit ranges from -8 to 7. It's given by this notation: 2 power 3 minus 2 power 3 to 2 power 3 minus 1. Okay, and if it is unsigned, it can store between 0 to 15, which is given with 2 power 4 minus 1. 0 to 2 power 4 minus 1. The upper limit is 2 power 4 minus something of that sort. Okay, and if it's 1 byte integer which has 8 bits, the the unsigned values you can store is -128 to 127. Whereas if it's unsigned, wherein all the numbers are positive, the values you can store is from 0 to 255. Whereas if it's a 16 bit integer, meaning a 2 byte integer or a normal integer sometime, okay, the value you can store is this much, from -32,768 to 32,767, given by this age -2 raised to power 15 to 2 raised to 15 minus 1, or if it's unsigned, this value. And most of our integers we use are 32-bit, meaning where the integers occupy 4 bytes, and this is the limit we have on them. And in our program, if you guys notice, this has 1 2 3 4 5 6 7 8 9 10 digits, and if you look at our value here at 46, we have already from 3, and this goes like another 3 6, and this is 10. There are 10 digits. When you add up these two, the sum is approximately 29,000 something. Okay, is approximately, from here it's 29 something, 10 digits, and the limit we see here is approximately let's see, 2,147,483,648. That's the limit we have here so the limit is approximately 2,147,000,000. But in our answer, if you look at this, if the sum of these two, the 47th Fibonacci number will be more than this limit. It will be 2,970,000,000 something, and so on. So that limit is getting crossed here. So this is an example, and after seeing this arrays, to make this a little more easy, what you can do is that you can use this kind variable, kind statement that we saw at long ago in the first programs. Okay, we can make this 8. Now if I were to make this 8, now the limit gets pushed even harder. Now it becomes a 4-byte integer. It gets a 4-byte integer and can take up values between -2 power 63 to 2 power 63 minus 1. So, and afterwards even there are even more longer ones available, but for our practical purpose, this is sufficient. Now watch this. If I save this, run this, now the executable is ready. Now what I do is that I give the same 50. Watch. Now it's not showing any error and it's proceeding further, and still there are a lot of values. Now if I just give up to like 100, watch, it's going out of control because of formatting. Okay, now I have to change the formatting here. Okay, so let's say I keep it like 25. Hopefully that limit does not crash. Okay, now if I do that, I give 100 again. Yeah. Unfortunately, after the 92nd value, even this is crashing. Because of this negative sign. We don't have any segmentation fault errors, but these are purely because of segmentation fault. These are purely because of the limits getting crossed, nothing more. And if you guys want to know why addition of these two becomes negative, it's because the limit is crossed, and the way in which there are ways in which the numbers get stored, and the computer using ANSI formats and all. Those formats explain you guys as to why numbers get stored and all. Practically means each number is stored as some kind of, I'll give a simple explanation. Each number is stored as a binary value, in which the leftmost digit is important for maintaining the sign convention. Now when these two numbers add up, what happened is the sign convention, when these two binary numbers add up, the leftmost digit also gets an increment. When that value gets incremented, what happens is that the sign flips. Simple as that. The sign flips. So if let's say if 0 is for positive and 1 is for negative, when these two numbers are added, that sign also gets flipped up, and then because of which you get a negative value. And there is this funny, this reminds me of a joke, not a joke, of a serious incident. Okay, why did YouTube change the view okay, let me type this again. Why did YouTube change the number of views type this psi. I'll explain you guys. Yeah, there's this funny thing. This is in Quora. Size Gangnam Style views counter in YouTube was actually this much. See, there were a lot. If you go to YouTube, the number of views is actually maintained by a variable. It's an integer variable that stores at the maximum this much, because it's made up of a 32-bit integer. or 4-byte integer as we saw in our program. But thing is, after the size Gangnam Style video was so popular that the peak limit of the number of views got hit, and because of which after that what happened is that after every view after this, the value became negative. But actually it did not become a negative, but they gave a lot of this person have answered it properly. And the thing is that to make sure that this does not happen, the views actually became negative. To make sure that this negative does not happen, they have to reset the the integer type for that value. If you guys want more answers, there are a lot of people to explain who have explained a lot here in their answers. You can just have a look at it, okay? And there are a lot of explanations here and all. You kind of have to the same thing. What we noticed in our program is similar to what happened to that video and all. It just causes a limit, and if you want even these values to be printed, we have to change this limit to 16. Hopefully there is a value that takes care of it. Let's see. Oh, it works. I have to give like 100. Oh yeah, thank God. 16 is just too big. 16 is just too big that it just worked fine. Okay, 16 is just too big. It will just work fine enough in our case. Now this way you got an idea of how different kinds of values can be stored in different integer types that are available in Fortran. See, each of these types, like the one that stores that takes 2 bytes of memory, the 4 bytes of memory, 8 bytes of memory, 16 bytes of memory, and all, each have their own name. Some call it short int, long int, long int, or very long int, something like that. That depends on different programming languages. Okay, the convention different programming languages. All you have to know is that regardless of the naming convention, it's better to know how much bytes of memory can each integer can store, and also that you can accommodate your storing processes accordingly. Nothing more. That will be of really good help. And moreover, we also saw about the dynamic allocation using this allocatable statement and this free statement, and this allocate statement, deallocate statement. And we also we also got to know the limits of the number of the digits, the limits of the highest upper limit, the limits of the values that can be stored by integers. And thankfully that it's a good thing we choose Fibonacci series, because we are able to cross the limit. Suppose we were to go for a geometric series, that limit will be too much that you have to change this value again and again to fit a lot, and we cannot go for a larger range. But this is good enough for us to have a look at. Okay, now with this I conclude this video. Thank you guys for watching. Hope you guys learned something interesting out of it. In the next tutorial we'll look at a little more things in detail about arrays, and I'll explain you guys about some of the indexing features that are available in arrays, and we'll go into multidimensional arrays and column ranking method. And after this we will definitely in the next set of videos we'll be following some array operations, using some intrinsic functions that are available in Fortran, and then finally we'll go into the major topic, functions and subroutines. Okay, once you guys get to know about function subroutines, you would have been very comfortable enough to do a large amount of computations on your own. Okay, and after that learning more, the more practice okay, let me rephrase this. After learning functions and subroutines, there is just one more topic called as modules, and that module topic will be like helpful for you guys to do a lot of job. And then afterwards we'll be looking at a little more examples, and and I'll explain you guys a little more concepts that may not be necessary on the immediate for the immediate purpose, but it will be useful as you go along for complex operations. So once again, thank you guys for watching, and see you guys in the next time.